Okay, hi everyone. From the other day, we were looking at discriminant, and the purpose of doing our discriminant is to determine the nature of roots for a quadratic equation. Okay, so what is our discriminant? It is our b squared minus 4ac. Where can we find this? We can find this over here, up here, inside this inside this part over here, right? Based on the formula, you see this orange little part over there, right? So that will be our b squared minus 4ac. Alright, so with this, we have three types of cases. The first case being d more than 0. When a discriminant is positive, you have two real and distinct roots, okay, meaning it will intersect x-axis at 2 points. For discriminant equals to 0, we have two real and equal repeated roots, or in short, it is just one real root. Okay, and you can say that the graph intersects x-axis at just 1 point, or it touches the x-axis. And for discriminant, negative means that it has no real roots, and the quadratic graph does not intersect the x-axis. So with this, we have solved some questions previously, and the thing that we want to pay attention is, number one, we can use discriminant, we can calculate the discriminant, and based on the value of discriminant, we conclude on what are the types of roots does the quadratic equation have. Okay, then the second type of question is that given the type of roots of a certain quadratic equation, we will need to make use of the discriminant to show certain things, or we need to make use of the discriminant to find values of unknowns. So we have three types of questions over here, right? Today we are going to push on to something further. We're going to push on to one more part of the one more part of the discriminant, okay, where we will talk about the always positive and always negative case, right? Okay, then for us, we will be continuing the notes after the few examples. So we are currently after try 9. Okay, and here we have another smaller concept that uses the discriminant. Okay, so the first thing that we have would be to look at where the graph is always positive or where the quadratic graph is always negative. So here we have two cases. So case number one, alright, case number one is where the graph is always positive, right? So you can see the description over here, right? The graph is always positive, or another way they will say that is this: the fx, the function, is going to be more than 0 for all real values of x. So whatever input that you have, your function is greater than 0. So as you can see the graph over there, alright, the graph will be a floating graph, and then it is always positive. So we want to recall what are the properties that will allow this to happen. So what are the properties that will allow this to happen? Number one, if you can see on the red part over here, right, on the red part over here, a is more than 0. The coefficient of x squared, right, is greater than 0. Right, then the discriminant is less than 0 because it has no real roots. It is a floating graph, it does not have any real roots. So these two conditions you must satisfy. The coefficient of x squared is positive, and that the discriminant is negative. Okay, now let's look at the second kind of case where it is always negative. Alright, so for over here we have a graph, right, that is always negative. The graph lies below the x-axis. Okay, and for this case, another description that they may say is that the fx is less than 0 for all the inputs x, for all the real values of x. Okay, so what are the conditions that will cause this to happen? Two conditions. The first one, a is less than 0. When the coefficient of x squared, a, is less than 0, it will be a negative graph. It is a maximum graph. So over here you have a maximum point, and the maximum point lies below the x-axis. Right? Second condition, the discriminant, the d over there, is going to be less than 0 because it does not intersect the x-axis, so the discriminant is less than 0. So for this case, the graph is always negative. So as you can see, right, as you can see, the graph is always positive or always negative when the discriminant is less than 0. So the discriminant less than 0 will cause these two situations to happen, but we will need to look at the a, the value of the a will tell us whether is it always positive or always negative. Alright, so without further ado, alright, let's move on to try 4 at page number 6. Okay, alright, so over here we have try 4. The question will be on top. Alright, the question is on top and the working space will be over here. Alright, so what will you do is you can take your time to copy down this pause and copy down this working, or you can just refer to the Google Classroom. Everything will be there. Alright, you can refer to that one and copy down yourself. Alright, so let's move on to try 4. Alright, let me explain what's going on here. So show that negative x squared minus 4x minus 10 is negative for all real values of x. So what we need to do is we need to show that this thing is always negative. Right? So based on the concept just now, right, we're going to use that concept later. So I'm going to show you two different methods. The first method being the one that we did previously, okay, but it is actually a bit long-winded. Okay, it's a bit long-winded on the what do you call it? The working. Alright, so let's take a look at the first one. So we can show that the function is always negative using completing the square. Okay, so the first one over here is we start off with this function. Okay, because we want the a to be positive 1, we need to factorize out the negative, right? So when we take out the negative sign, when we factorize out the negative sign, we have a plus 4x and plus 10. Next, what do we do? Completing the square over here, plus b over 2 square minus b over 2 square. Then the first three terms will be completing the square to x plus 2 square. The last two terms sum up together to give my 6. And over here I have my when I expand the negative, I will get my negative bracket and negative 6. Then we move on to the next part down below. Okay, so over here we have we start off with the square first. So since anything square is positive, the negative of that will be negative, okay, less than 0. And we have our, okay, wait, let me show you. Okay, let me use my trusted pointer thingy. Okay, it's here, right? Okay, so since the anything squared will be more than 0, okay, then negative of that thing would be less than 0, okay? And we are going to add negative 6 on both sides, which does not change the order. So when I add negative 6 on both sides, so the function, the fx, is going to be less than negative 6. Right, so let me add one more line here. Alright, so this whole thing is going to be less than 0 because it's already less than negative 6 is definitely less than 0. Okay, so this whole thing is less than 0. We need to show that the function is less than 0. So just nice, this whole thing is less than negative 6, which is also less than 0. Okay, so it means that this function is always negative for all real values of x. So this would be method 1 of solving our equation. Alright, so let me show you method 2 of solving this thing. Alright, so for method 2, right, the question is still here. Yeah? So for method 2, we can use our concept earlier. Right, the concept earlier is that we need to show two conditions. First condition is that the a must be negative because it is a negative graph, and the b and the discriminant is also negative because there's no real roots. So number 1, the first condition up there, let me fly up there. Okay, let me fly up there. So the first condition over here, alright, this line over here. Okay, I don't think you can see, but okay. Alright, so for this line over here, for this function, the value of a, right, the coefficient of x squared is a negative 1, and this coefficient of A is negative. So first condition done. Now second condition, we need to look at the discriminant. Okay, so for the discriminant, let's calculate off the discriminant. You find that it is actually negative 24, and negative 24 just nice is less than 0. So this function is going to be negative for all real value of x. So means then this will be our conclusion, because it hits two conditions. It hits condition number 1, it hits condition number 2. For it to be always negative, right? So based on our working over here, okay, I will let you judge. Okay, wait, so let me reposition myself to somewhere more strategic. Okay, alright, so based on our working over here, we have two different methods. Okay, the first method will be what we've learned at 1.1. okay, but it's going to be a bit long-winded. Okay, and it's going to make use of inequalities which most of us are still not too familiar yet, right? For method 2, it is a bit shorter, a bit more efficient. We just need to look at the value of A, we need to look at the value of D, then we can prove that this thing is always negative. Okay, so with this, we will then look at the next example, right? Okay, hi. So the next question will be at page 12, and we'll be looking at try 10. Okay, so for try 10, the question goes like this. So show that this graph, right, y equals to negative x squared plus 2kx minus in brackets k squared plus 1 lies completely below the x-axis. Right. So before we start, let us take a look at this part over here, right? The k squared plus 1. So we have to more or less like expand it so that we can have it in a general form. Okay, so let's take let's not do the long way, and let's try to do it using the two conditions, which is looking at A and looking at discriminants. Okay, with that, let's come here. Alright, so over here, we start off with the one above. Let me reposition some things first. Okay, like this. Okay, let me reposition some things first, and let me like express this as a nicer form. Okay, a more completely honest form like this. Okay, so then let us invoke the two conditions. Number 1, let's check the A. The value of the A is going to be negative 1. So since A is negative 1 and negative 1 is less than 0, so we hit the first condition. First condition is done. Okay, let us look at the second working step over there. So for the second step, we make use of the discriminant b squared minus 4ac. B is, okay, so A is negative 1, B is your plus positive 2k, C is your constant without the x's. So this chunk will be your C. Okay, so b squared, which is your 2k whole thing square, minus 4ac negative k squared minus 1. Okay, we expand so that we can just sub in nicely over there. Expand carefully. You should be getting 4k squared minus 4k squared minus 4, and d is equals to negative 4 over here. Right, so this value of d is negative, so we hit our second condition. Right, so first condition A is negative, second condition discriminant negative. So because both are negative, the graph of y lies completely below the x-axis. Okay, it is always negative. Okay, so this ends part 1 of try 10. Okay, so now we are at part B of try 10, and the question is saying that show that 1 over 4x squared plus kx plus k squared plus 1 is always positive. So to show that something is always positive, A and discriminant. So discriminant definitely less than 0 because it does not touch the x-axis. Then for the coefficient must be positive. So let's do one by one. Okay, so the first one would be, let's do the discriminant first. So the order doesn't matter. So for the discriminant, right, this is our A, 1/4. our b will be plus k, our c will be plus k square plus 1. Alright, so b square minus 4ac, so b square k square minus 4ac, so minus 4ac over here. Okay, so just nice we form them, we expand carefully, so the 4 and 1 over 4 can cancel out just nice, and we need to expand the negative carefully. Okay, so we have k square minus 1, so just nice we have a negative 1, so d square is negative, no real roots. Okay, first condition. Second condition down here is a is more than 0. This is a positive graph. Okay, a positive graph without touching the x-axis is going to be always positive. So the conclusion is this graph, this function is always positive, right? So we make use of the two conditions, a more than 0, d less than 0. Okay, so this ends our lesson on the today for HBL. So please use this time to please use this time to finish up the exit passes that we have given, right? And when you come back, you can hand them up, and we'll go through them in time. Okay, so one last time to summarize what's going on over here. Okay, to summarize what's going on over here, we are at this point where we were looking at discriminants. Okay, and the discriminants have three cases. When discriminant is positive, you have 2 real roots. Discriminant equals to 0, 1 real root. Discriminant less than 0 or negative, we have no real roots and it's a floating graph. And because today we just looked at 2 cases where the graph is either floating or sinking, or where there are no x-intercepts, which are when the graphs are always positive and always negative. And the summary is that we use these 2 conditions to show that the graph is always positive, always negative, or to show a certain function more than 0, certain function less than 0 for all real x. Okay, so we look at A, we look at discriminant. So this ends our lesson for today. Alright, so have a good day, see you tomorrow in school.